Hello. I've got a few hours before my flight to Vegas, and I'm finishing up my talk. Unfortunately, I'm not able to do this live. I really wanted to, and I much rather prefer doing these talks live. So what is this talk about? What's this point that you're sitting here watching this video? Well, hopefully, if we get things right, you're going to figure out how to take one protocol, catch it, demodulate it, replay it, and get it to trigger another RF protocol on a completely different frequency. I'm talking about the Key Fob, the thing that you use every day that sits in your pocket that has multiple security protocols that they put in place. I'm not going to teach you how to steal cars today, but I am going to teach you how to understand the process that is used to protect them and how multiple frequencies cross over each other to be able to manipulate each other. And that's what we're going to do. But before we move too far, I want to say a couple things. The only reason I'm able to do talks like this is because of guys like Mike Walters, the individual behind Inspectrum, Mike Osmond, the individual who brought software-defined radios to the forefront for individuals like myself, Jay Boone, maker of the Portapak. And by the way, if you're buying the cheap knockoffs of either the Hack RF or the Portapak, stop. Get the real thing. One, they work better, and two, those individuals put the time in to do it right. And Iceman, if you're doing anything in the RFID world, you should probably know who he is, and if he isn't, you're probably behind the times. I recommend you follow him. He's incredible. Some of his stuff we'll be talking about as well, because we're going to be talking about 125 kilohertz all the way up to some of the VHF bands. Matt Knight, another individual who's just been huge and instrumental in helping me learn. Tim K, you probably know him from the dog collar challenges of the past, an incredible individual. All the guys at SensePost, they were actually the first people that introduced me to cyber when I was still living in my previous life. Darren and Shannon, who were just incredible people and allowing me to be on Hack 5 and did so much for helping me learn before I even knew what a hacking convention was. Both of them were and are incredible individuals. The RF Hacker Sanctuary, let's face it, that's the reason that we're all here right now, and the work that they do is incredible, and please make sure you're giving shout outs to them and that you're supporting their cause. And I know I'm going to mess up the name, but Jopo, who doesn't enjoy watching a video that starts out, "My fellow hackers"? He does an incredible job with Universal Radio Hacker, and we will dig fairly deep into that during this talk. Another one is Erwin Reed, who is one of the members with the Mayhem firmware that you use for your Portapaks. Absolutely incredible stuff coming out of them. I don't know some of these individuals. Most of them I do. There's a handful that I don't. But the person that I also want to reach out to is Marco402, one of the people who keeps up with the RTL 433. We will be covering that. These are the tools that you should be playing with if you're playing in the RF world. These are the tools and the software and the things that are out there that can make you do some incredible things. So I'm not saying that I'm going to do anything incredible, but I'm hoping that I'm going to be able to show you some fun things you can do that will get you thinking and moving into new areas to hopefully find some of your own 0 days for the first time and some of your own exploits. And on top of that, it's just fun. And most people have access to a vehicle of some kind or another. Welcome back. So our next step is we want to understand that relationship between the Key Fob and our vehicle. We need to understand how this works, and we need to understand what the mechanics are behind it. Now, this is going to represent our vehicle. So, if you have a passive entry or a push to start vehicle, this is going to describe how that works. If you don't have one of those, there's still an RFID process going on at 125 to 136 kilohertz, but we're only going to represent passive entry and push to start vehicles. Now, as your vehicle sits there, it isn't making any noise, and that's fairly common. Apologize. That's fairly common. And the reason that you're not making any noise from the vehicle is most of them will have some kind of motion sensor on the door. Some require you to actually push a button or touch it. Others will actually use motion sensors so that if your hand goes behind the handle or if you get within range of it, it will then send out a signal at what we're going to represent at 125 kilohertz. Now, many of you are used to this because of your building access badges that you use. This is where we start dealing with some of the Proxmart stuff and some of the RFID things. Your key fob, for example, this one, normal frequency is 903.4 megahertz. However, it does have an RFID chip in it. This chip does not broadcast. This chip only receives, and when it receives, it then opens a gateway inside of the key fob on the board that sends out the 903.4 frequency. So as you come up and decide that you want to enter the vehicle, when you touch the door handle or you set off that motion sensor, whichever way you do it, your key fob receives a signal at 125 kilohertz. Typically, this is only going to happen from very close distances. Once that happens, your key fob, remember, it's not necessarily passively collecting. It is actually powered by a battery. So it will receive that signal. When it receives that signal, it will then trigger its unlock sequence. When it triggers the unlock sequence, it sends that at the 903. There's actually multiple frequency it will go at, but we're going to say 903.4 megahertz. Okay, there's a 902 and a 903 for this particular key fob. Now, this is not just designated to one make and model. I've had this be successful on multiple brands of vehicles, different makes and models. So now what happens is you get inside of the vehicle because it sent the unlock. Now when you get inside, depending on what the vehicle is, either when you push the brake, because most vehicles require you to push a brake when you hit the start button or to be able to put it in gear, or when you push the start button, the vehicle from another completely different transponder will send another 125 kilohertz signal. When it sends that other 125 kilohertz signal, which is typically in the center column, your vehicle sends that to the key fob. The key fob then sends a message that says, okay, go ahead and start. It sends that at its normal frequency. Now, because we're doing this, the vehicle will then receive that signal. It says, okay, I've challenged, you've replied, and it will allow you to start. But what if? What if we could demodulate this signal? Well, those of you that have done some of my challenges in the past know you can, and we're going to show you again how to do it. But is it the same signal? Well, we're going to find out. But what if we could capture this signal at 125 kilohertz and replay it? Do you think we could make this key fob talk again? Well, most vehicles use a rolling code. Rolling code means that if I see the same signal twice, I'm not supposed to listen to it and I'm not supposed to respond to it. Do key fobs listen for rolling code when they receive a signal from a vehicle before they send out their normal frequency, which is 315, 433, 868, or the 900 bands for key fobs? These are some of the things that we're going to look into. Now, one of the first things we have to do is be able to understand if we're getting the same message or if the message actually changes. So we're going to take a quick break. We're going to look at URH. We're going to look at RTL 433, and we're going to figure out how do we demodulate and get this information from this key fob. And then once we do that, can we use some of our normal software-defined radios to actually capture and replay 125 kilohertz? And then can we do it with the Proxmart? And what's the difference and what information do we get? Hello. So, our next step we already talked about. We have to figure out how do we distinguish if this key fob is giving us the same signal or not. Is it the same lock or unlock sequence that it normally gives? How do we figure that out and what do we need to do? Well, we're going to look at a couple different features. One, right now, I have an RTL SDR attached, and I already know that this key fob will work roughly around 902 megahertz to 903 megahertz. So I'm just going to go ahead and put 903 megahertz in here. I can leave it at 1 meg, that's fine. Now, if I go ahead and hit start, that did not work because it's being used by something else. Apologize. LSDR hopefully will work. And that sucks. Apologize. And again, going live, that's where occasionally things happen. So we actually had one of our hubs disconnected. But that's okay. We go ahead and we hit start. Our hub's connected and we're at 903. Now where we are currently, we're not getting a lot of signal from this or anything else going on. This is the key fob. So as I push the button, oh, we got some spikes. Now, we're not worried about this stuff down here, right? Little shadowing going on. But if I put the center of this and I'm in the spectrum analyzer mode, in case any of you haven't used in Spectrum, to get to Spectrum Analyzer, I just open URH. I go to Spectrum Analyzer, and that gives me this amazing window here to where now I try to put myself right in the middle of it. Oh, that seems to have put me pretty well where I need to be. Good. So now I figured it out. Go ahead and say okay. I'm using 1 meg. My gain seems to be okay. Oh look, 903.4. Looks good. So I can go ahead and close my spectrum analyzer. I can now say I'm ready to record. Now at the point that I'm ready to record, we are going to press the unlock button because we know that the unlock button is one of the things that gets used. So we let this feed through. I press unlock. I press unlock. I press unlock. I hit stop. Now, when I hit stop, I'm going to go ahead and hit save. Now, when I go ahead and save this, I look at what I have. Everything looks good. I'm going to go ahead and save this. Now I go ahead and close. Now, everything that we did from the spectrum analyzer, those settings got saved when I went to the record, so I knew that I'd be in the right place. Now, this is where we start playing with some of the magic. So when I look at this, right now it's not giving me any noise levels or anything else, but I do have things that are definitely falling off the baseline, so I'm okay there. There's a few ways that I can go about this. If I hit auto detect, it will try to figure out what's going on. If I come up here and I start adjusting noise, all right, I can do that. But if you notice, I wasn't quite dead center, and when I start setting noise, it's going north faster than it's going south. Ugh. So I could change my center to 0, but that still isn't quite helping me. Now this is where Universal Radio Hacker is such an incredible tool. I can come down here and I can look at this in the analog view, or I can come down here and look at it in the demodulation view. If I come to the right, this Y scale gives me the ability to make all of this bigger or smaller, cleaner, more robust, right? That's still pretty dirty. But if I come down to Spectrum Analyzer, well, look at this. Now, I always like to make my FFT window as small as possible. It just seems easier for me to deal with. By adjusting my minimums and my maximums, I can actually clear it up a little bit of what I'm actually looking at. And now if I really want to, this Y scale, I can actually make everything a little bit bigger. Now, we don't have any gaps. What we have is either a frequency here or a frequency here, which tells me we have FSK, most likely, frequency shift keying, right? Hopefully to FSK. So I'm just going to highlight that. I left click the mouse, I highlight it, and then I right click and I say, let's just apply a bandpass filter. And now this pops up. But normally it will go ahead and it will have a ton of noise. So I'm going to delete all the noise. I'm going to start with 0.00. Let's just give it a whirl and say 6. Again, our Y scale will let us make this bigger. All right, that would probably work, but I want to refine that down a little bit more. Let's try 2 and see how that does. That's pretty good. And now I'm going to go ahead and say, hey, can you auto detect and tell me if you find anything? Now when it auto detects, it's going to try to figure out what's going on here. Okay. Now, I'm not good at reading binary, but I like hex. Okay. So I can start looking to see if I can read the hex off of this. Okay. So if I'm having trouble with the hex, I can go ahead and say, hey, auto detect, see what you see. All right. Let's go to the demod view. I'm going to make this a little smaller. Oh, it looks like this is a little high. In the auto detect, it was actually trying to read this top layer where if we look here, notice we have high points, we have low points. By scrolling my mouse, I can actually bring this in and out and be able to see a little bit cleaner. And I can try to make sure that what I'm seeing is nice and clean. And that will really help me. Now if I hit auto, it tries going up again, so I come here. Now, this is one of the really nice things about Universal Radio Hacker, right? We can go in here, we can look at it, we can clean it up. You can also come down here and move some of your filtering averages. And this is going to help you be able to look and really see what's going on, right? Now, when I look at this, the auto detect is trying to tell me that there's 20 samples per symbol. So let me dig in here and see if we can find something like a preamble, right? Oh, we have 2 signals. We have a signal, then another one, and that seems to be consistent. Oh, and look how consistent these are. So I'm going to go ahead and just see roughly how wide this is. It's about 250. All fives. For a preamble, that makes me feel pretty good. Okay, let's go up to analysis. Now, on the analysis tab, you notice that we have all this information going on. Both the signals we got are being represented. I don't want the signal that did not use the bandpass filter. The bandpass filter basically says I'm only looking at this information, this noise, nothing above or below this frequency, and it really cleans things up. So if I click here, now I only have to look at this. So if I highlight all these, let's look at some of our decoding. Now, I know that Ford is notorious for using Manchester 2. Okay, so now if I go to hex and I look at this, I can see that we have all zeros up here. So this one right here is probably kind of a bad catch, because after that we have all F's, skip, all F's, skip, all zeros. Okay, so fairly consistent in what we're getting there. And let's see, FFE, that's E3059, 3059. Okay, now I'm in kind of a unique situation because I deal with this all the time and I work with these, so I know that what I'm looking at here isn't too bad. We're looking pretty good. It doesn't seem too bad, and we're getting some of the key fob identifiers in here. I have the ability to actually look into my vehicle and know what the identifiers are because of some of the techniques that I use. So right now, off the top, looking, okay, not feeling too bad. Now, if we came back here and we saw anything that we thought was a little quirky, what we can do is we could always clean it up a little bit. But right now, I feel okay with what we have, because the ones that matter to me are these ones. We have our preambles, which is basically saying, hey, 101010101010, pushing through. We're using a Manchester encoding, but it's letting it know, hey, I'm getting ready to talk. And then we get a conversation and a conversation and a conversation. So because of that, I feel okay with what we have. I think we can move forward, and this lets me know that we're probably doing okay. Now, if you notice, we have a 0-2 right here at the 13 to 14. This is where I'm going to get my lock or my unlock feature. Well, if I have any idea what I'm talking about, then what that would mean is, if I were to come over here and say that I want to record another signal, right? I'm going to hit record, and now I'm going to press unlock, 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 lock, 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 unlock, unlock, stop. I'm going to go ahead and save that. Once I've saved it, it will go ahead and just get added to all the work we've already started to do. So now, here we have this right here. It's not real high off the baseline, and again, my center point, just like before, seems to be a little bit off. So let's go to our spectrum analyzer view. Okay, I'm going to make that small. I'm always going to make my FFT window small. That's just me. For me, it just seems easier. I scroll with my mouse, and now I'm able to come in here and look a little better. I come to my Y scale, I bring it up. I can change some of these parameters if I need to, just to make it a little cleaner if I wanted to. Okay. And now I just hold over where I want to look and I scroll. And I've got a really good look right here. All right. I highlight what I'm interested in. I apply my bandpass filter. And now when I come down, I'm going to go ahead and again change this to 0.005 we'll start with. Let's make that Y scale a little bigger. You know what? 001. You know what? I feel okay with that. So I'm going to go ahead and go to my demodulated view. See how it looks. Not horrible. Okay. Can make that a little smaller. Now where you will run into problems is if any of these are hitting where you're starting to have multiple frequencies, which with some of these vehicles you will have that happen. So that's why sometimes you'll have some differences in what you see. So I feel pretty good with that. I'm going to go ahead. I'll tell it to try to auto detect. When I do that, you can see again it's trying to auto detect in the wrong place. So I put it back where I feel it's good. Change it to hex. Okay. Got that going. There we are. Now, one of the other things that I'll do when I look at this is if I think that there is a group of these that seem way too off, right? I'm going to up this a little bit. Okay, that all seems to be fairly centered. Let's look at our others. Okay, because occasionally you'll have some of these that are a little bit off and they can create an issue. Okay, so once we go through, we're able to see all those. Now we have the ability to come back over to the analyze, and I can pick just the ones that I want to see. Say, okay, hey, I just want to see those bottom ones, right, that came through. Now, again, when we come back here, it's still trying to put us at 20. So I change it to 250 and see what happens. That seems to be a little bit better, like we had before up higher. Okay. 555 4C. Yep, that's looking good. 65A. Yep, that's all looking much better. Now I'm going to highlight all of this and I'm going to switch it to Manchester 2. We are a little cleaner this time than we were before, and we're able to see that we've got E3059. Let's look at this one. E3059, E3, well, you know what? I wonder if there's any, I don't want to know about this right here. So I'm going to hide this top column. I want to know if any of these other columns, because we know that we have the preambles and we know that we had some issues with this. So why don't you mark the differences? And the protocol I care about is the one that has all of this listed out. So I hit mark. So that one's identical. We come down. This one's the exact same one, so it repeated itself. This one is exactly the same up to here. Up to 18, this is the same. Okay, good. Now as we start coming down, let's go to the very bottom one. And what we're able to see is that the very bottom one, we have everything the same until the 8. Now, as we move up, what we're going to see is 02, 01, 01, 01, 02. Do you remember when I was doing locks and unlocks? 01 and 02 at the 13 and 14 mark is where you get the distinction of lock versus unlocked. And by being able to distinguish that, we now know that we're able to start telling the lock and unlock sequence. We can start telling that there is a rolling code. We're able to also tell this preamble area here, or I'm sorry, this synchronization that seems to be the same. And as you dig in, what you would find if we had multiple key fobs is that this is where it synchronizes, and then this is where the actual key fob identifier starts, is from 5 to 12. You will actually get the key fob identifier. So if any of you are doing the challenges that I do, that might be of interest to you. So we're able to demodulate the key fob itself. Okay. Now we want to know, that was me pushing the buttons. What if we use something else to push the buttons? That's what we're going to do next. Okay. So we figured out what it takes to be able to record a normal frequency that most of us are used to. And by normal frequency, I'm referring to anything 23 megahertz to 6 gigahertz, 1 meg to 6 gig. Some of them are 75 or 73 megs to 6 gig. It all just kind of depends on the radio. But what we need to do is something a little different. We could use Proxmart, right? We could take one of these and set it up and do some LS sniffing, because we know that these work in that LF band, that 125 to 136 kilohertz. But hopefully we'll have time to get to this a little bit later. This is one of the things that I like to use to double check the other things that I've done. This is where Iceman comes into play. He's a genius with this stuff. Hotel keys, building access cards, everything else. The difference with what we're doing is the keys themselves typically do not send a message back. You typically get the message from the vehicle, and the key receives it, and then it opens a gateway to fire at its normal frequency, which is one of the ISM bands of 315, 433, 868, or the 900s. So we could use a Hamitup. So a Hamitup is a great little product. The way it works is I hook it in line with a radio, and when I hook this in line with a radio, it will actually take whatever frequency I set that radio to, and I just put it 125 megahertz over what I want to listen to, and then it will let me hear what I want to. So if I listen to 125.125 megahertz, that would drop me down to 125 kilohertz, because it automatically drops you down 125 megahertz from wherever you are. Hamitups are great. Highly recommend them. They can make a radio more versatile by being able to get down into those lower frequencies. Great tool. With a Hamitup, I can use a simple RTL SDR to be able to drop down into some of those HF frequencies. And I love that. However, I'm lazy. I didn't want to have to hook anything else up. Now, I do love this tool, but I needed a little bit more range than this was able to give me. I have a lot of sniffers at the RFID range. I take a lot of RFID building readers and I turn them into sniffers to be able to clone building access cards or stimulate them or try to get data off of them. So I wanted to know what I could do that could make things a little bit more beneficial and could give me better range. Now, one of the other things that I do recommend using, if you don't have any of these other tools, is you can use a loop antenna. A loop antenna that you use for tracing, doing trace outs on a board. A loop antenna works really well, very, very close range for this LF range. But I was watching a video by Mike Osman, and he made a small inductive loop, and he was listening under 1 meg. Now, while the stats when you buy this listed at 1 meg for its lowest frequency, what I found was that if I did a little bit of modification, I was able to listen to this 125 and 136 megahertz extremely easily. So this right here is it's just a simple card reader. That's it. I'll put it down and you'll see that it's just designed for being able to read cards. That's all it is, for getting in and out of buildings. Unfortunately, I'm hoping that we'll get a good read on it. If not, I'll read it to you. Again, there we go. So this is a Prox Pro. This actually gives pretty good range. In fact, the standard building access card, I'll get anywhere from 8 to 10 inch standoff with this little guy. But I didn't use this as a card reader. I unpotted the guts. I took the card reader out. Everything that would normally use this inductive loop that's around here, right? That inductive loop is what normally will stimulate a RFID card, feed it energy that it turns to electricity that it then uses to basically stimulate a capacitor and spit its signal out. And then it reads it. I got rid of all the guts. I then soldered directly onto the ends of this, and I used Cat 5 because I wanted to match the diameter of the cable best as possible. I then went to Amazon and bought these little cheap couple dollar balins. I connect the Cat 5 into it. Pretty simple. And then I connect it to my Hack RF. Because while it's not perfect, and it definitely isn't the best antenna or the best radio for listening to this frequency, if I'm using a Hamitup, or if I'm just using the Hack RF or the Portapak Hack RF combo, this antenna and this balun mixture right here works really, really well for listening. I've also taken the much larger card readers that I can get a few feet out of, and I've modified them, feeding them into a balun and using a much thicker gauge wire as it comes off here, and I've had really good success with it. So that's our next step. I'm going to go catch some signals from the vehicle. I'm going to bring them back, and I'm going to replay them at 125. And all I'm going to use is a Portapak with the Hack RF radio attached to it, because that's how they work in unison together. And we're going to see, one, can we demodulate the signal? And two, can we make that key fob that would normally only respond when the vehicle talks to it to continue to talk at its normal ISM band frequency? So that's our next step. Okay, so up here we have an RTL SDR listening at 903.4 megahertz. Now if we remember, that is and we have the spectrum analyzer. This is URH. if we remember correctly, that's the same frequency that our key fob works at. And down here, I just went out to the vehicle, I pressed the brake a few times, and I captured the 125 kilohertz signal. As you can see here, this is broadcasting at 125 kilohertz. Now, I will tell you, I'm not going to give all the details of this, mainly because I'm not an advocate for car theft. But you will not see this if you don't change some of your settings in your Portapak. You will not see this if you keep 500 for your rate. You're going to have to adjust and change it. Now, with that being said, at this point, if I come down here, here's my little finger, and I press for it to play in a loop, we can now see that it has caught that signal and it is playing it in a loop. Okay? I can only show you so much with detail, so I'm going to have a little bit of faith in you. Now, as I pull this out, you can see that it's continuing to play. Right? There's no magic, no hijinks. It's continuing to play. Now, watch up here. This is the key fob. I put it in. Oh, as soon as I put it inside that loop, it is now receiving this signal at 125. And do you see what keeps happening up here? So now that you can see where that is, let's focus back down. And I want you to look at when this plays a signal and what happens up here as it does it. So I'll go ahead and clear it. As the signal, oh, there it is. And it plays its signal again. So, now that we know that, we can go ahead. We still have our other data here. We're going to come in here and we're going to now record a signal. All of our information was saved from before. We're going to go ahead and click start. Now, as I'm doing this, you can see how this is rolling through. So you can watch this as it happens. And I click. Make sure that I've got everything set up. I'm going to move my antenna for my RTL SDR just a little bit closer just because I want to make sure we get good clean catches. And I hit start. Boom. 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 Okay. Stop. Save. Okay, now let's see what we have here. I'm going to go ahead and stop this from playing right now. Okay, I just hit stop. You can see 125. Now, let's open up our Universal Radio Hacker. Come back into this, and now if we come all the way down, we're going to see that we have a new set of signals. Now, by scrolling your mouse wheel, you'll be able to see all the signals you have. These look pretty good. They're coming off the line. If we raise this up, we can see just slightly off center. That's okay. I'm not too worried about that. I feel good. In fact, I could almost just make the noise big enough as it is if I wanted. 0.020. And if I hit that and just said, hey, why don't you try to auto detect? Still a little bit off, but we can look and see what it winds up doing. Right? But before I do that, let's just go ahead, go into that spectrum view because I know that I'm probably going to have issues. I immediately always make my FFT window as small as possible. Just me. I just have better luck with that. I'm going to zoom this in, make this a little bigger, change my minimums. Now when I zoom, Let me zoom into this. All right. And again, I can see that it's FFT because I have, oh, I'm sorry, FSK. Well, it's definitely not on-off keying. I don't want to say I could tell for sure this is FSK, but I know that this is frequency-based, not amplitude-based. Because when I don't have a signal here, I have a signal here. Now, I come up, I go ahead and, actually I'm just going to go from strongest point to strongest point right there. And apply bandpass filter, see if that works. Okay. Again, this red means noise, so I'm going to have to change my noise floor. 005. See how that looks. Make it a little bigger. That doesn't look too bad. Let's see what happens when we say, hey, let's auto detect this. All right. Now, a couple things I want to do. I'm going to go ahead and come down here. This isn't looking too terrible. Let me see if I can find a preamble. I can always scroll. There we go. Find the first one. Let's just see what we're seeing. The ones that are consistent. Okay, so we do have a little bit of difference in what we were seeing before. So that 50 very well could be acceptable. So now let me go ahead and go to this view here. Now I don't want my initial signal. I'm going to come all the way down and I'm going to look and see what this looks like. Now you see how this looks very different than up here? That's because this, if we click on it, is still using non-return to 0 for setting its encoder. We're going to use man 2. Now when we switch this to man 2, we can see that there's some slight changes here versus what we had before. Right? So this is not the same information. In fact, one of the things that we see here is that we don't get that consistent preamble that we got before. In fact, what happens is it gets challenged and it spits its data out and it says, hey, here I am. So we know that they don't use the same information when they do this, but let's do this. I only want to look at this information to see what's going on with it. Okay, so now if I do this and I say mark differences in the protocol, it's only going to go off this first one. So we can see that these first two were not exactly the same, but they were close right up to here. This one changed at this point. Then we changed here. Oh, and then look, it repeated itself. Why? Because I hit the brakes 3 times. And when I did that, each time I hit the brake, while the beginning of it stayed the same to let it know what, it has a sync here and then it has what the command was. Then what it actually does is here, this is where we actually start getting into a timing sequence. So I'm not going to dig too deep into that. There's a lot of timing that needs to be involved to do any exploits past this point. But we can see how we have identifiers inside of here, and we can see how the signal that was sent 3 times from us wound up sending this information back right here. So that makes it really interesting for us because we are now able to look at this, be able to tell what's happened, and we just took 125 kilohertz. I set it next to my center console. I pressed the brake for this vehicle. Some of them it's the start. If you have passive start, some of them it's the brake. It sent in RFID at 125 kilohertz quarry to the key fob. The key fob answers at its normal frequency, but it answers with a different value than it would if you hit the keys themselves. So now that we've done this, now one of the things that we want to do is figure out what is this information, what is the 125 kilohertz signal that is coming off or away from the actual vehicle itself. So that's one of the next things that we're going to do is I'm going to get that set up, and we're going to look at how we demodulate the 125 kilohertz signal. So we've taken a signal at 125 kilohertz. We've captured it with a Portapak. We've now replayed it to the key fob and been able to get the key fob not only to answer, but to actually repeat itself multiple times. And as you look at this, we can see with consistency that other than the rolling piece of it here, the rest of this starts falling in line fairly well until the rolling code starts. So what that helps us do is actually figure out where timing ends and where actual rolling code begins. Those of you that have seen my talks on some of the other key fob attacks have seen me talk about that, where you have sequencing, where you have timing, and where you have rolling code, and then where you have checksums. So we've been able to catch a signal at one frequency, interact with a piece of hardware, and get it to respond to us at a completely different frequency. And it is actually using a different sequence to come back to us with. So I'm going to take a quick break, set this up, and then we're going to see if we can demodulate the 125 kilohertz signal. All right, so we're back, and what we wanted to do was talk about this LF signal, this low frequency signal. We're using a software-defined radio, Hack RF right now, to be able to do this. There's several ways that we can capture a low frequency signal and high frequency signals, and we're mixing them together by making the low frequency signal talk to the key fob and then have the key fob send its high frequency signal. The problem is, on the low frequency side, I'm not great at the RFID things. The Proxmart 3 is an amazing product, so I figured if we were going to do this and do it right, I should go to somebody who knows this better than me. So right now, joining us is Iceman, and he's going to walk us through how we're going to take this signal, catch a low frequency signal, save it, and demodulate it, and be able to do that side of it using the Proxmart. So by combining these tools and these two worlds, we can completely understand the picture that we're looking at about how a key fob communicates with a vehicle and how a vehicle actually communicates with a key fob. So I'm going to go ahead and open a terminal, and then Iceman, if you just want to talk a little bit as I go through this and explain and correct me when I make the many mistakes I'll probably make. The one piece we're not going to show on video here, just because of time and location, is the way that I get a signal with the Proxmart is using these LF sniffs, and Iceman has just released this 3-part series that is incredible, teaching you how to do the steps that we're about to do. And why we're doing this, realize you can take the Proxmart, go to your vehicle, put it in the center of your vehicle where the LF signal is strongest. That's typically where it's going to be. And when you hit your brake or the start button, you can do the sniff techniques and then be able to evaluate the data. So you can record it with your Hack RF or your Portapak on the LF side, or you can use the Proxmart. So, Iceman, thank you for being part of this. I really appreciate it. And we'll go ahead and get started.
Well, thank you, Woody. It's an honor to be here. I like these crossovers. Let's show me. What have you done?
Well, so right now, I've just fired up my Proxmart. I have it sitting here. So if I was in the vehicle and I wanted to use just this to catch that LF signal.
Yeah. You would do something first, but we need to know when the sniffing should start. So type in lf config -h, we would see the help text for the configuration where we want to set the threshold. If you look a little bit up there, it says -T. I suggest that you run this command with lf-config -T 20. That gives you a proper threshold to capture the signal and make sure that just capture that part. The reader will give you quite a strong signal, that's why. So we're going to capture on that one. As you see here, the threshold is set to 20 and we're all set. The next thing you would do is lf sniff. And while you're doing that, the Proxmox should just now the signal. We're not doing it properly right now because of the Portapak. But if we interrupted here, you would have collected a signal.
Yes.
And we will just do a quick breakout here, and you would save this signal, and in order to look at this signal later on. And that you would use. I think you need to press your button as well on your Proxmox right now.
There we go.
There we go. You would need to type in data space save space -F and then space and then your file name that you want to save as trace. I suggest that you keep on a date or an area where you did this from, or model of the car.
Yep.
Yeah, exactly. And then you press enter and you will have a file saved.
And
What we're going to do for this situation is, tell us, Woody.
Well, so we've already saved a file that we went to the car and we actually captured from the vehicle. So now what we're going to do is we're going to pull that file up and we are going to load it. So we are going to data load, tac F for the file name, and then I already have this file saved and I save it in the directory that I'm running the Proxmart from. So wherever you start that as your parent directory, that's where you need to have this file so it can reach to it. Otherwise, you're going to have to point to where the file is on your system.
Oh, yeah. And now we want to look at that. You just bring out the plot window with a data space plot. Data space plot. I have to look it down here. So if you wonder why I'm looking up and down, I'll try to look what Woody is doing at the same time. It's kind of fun. This is a very strong signal if you look at it, right, Woody? I think if you zoom out, you can see the whole one. It's kind of short. I think it's only 4,000 samples. Yeah. So it's kind of strong. You see it flattening the tops. If you zoom in very much right now, we can see. I will just show you. If you take the mouse and you see, it's like a cut-off top. This is a very strong signal. So that's the Proxmox has been cutting off the top edges on the lowest part of it. So it will. This is a good capture, basically. So we can do something with it.
Okay.
We would actually try to see and analyze this one, and I would try to run the data space detect, and then we do a -A. This is what I would suggest in this one. By some know-how. It gives you the clock rate, and it finds a proper one. 32 is a very common ASK clock rate. So that's a good sign for us. As Woody sees, we have now got the light gray vertical grid lines to indicate as a clock that fits into this. And now that we know that ASK is here, we can start doing the data raw in order to demodulate this one into binary. So type in raw and we do --AR, which means ASK raw. And lo and behold, you got it. You got a signal that actually, if you look at the binary patterns of this one, it is very much 0, 1, 1, 0. So I would even say that this is ASK Manchester. But take a notice first on the first line of that output there is 2 dots. This is something that doesn't fit into the signal of a raw. Something is missing there. So, but I think we got good capture of the rest of it. So let's print this one. No, let's go for data raw and go for data raw --AM. See if it's a Manchester encoder. And it was. All right, great. So this makes more sense for it. And those dots that we saw failing in the beginning, it makes even more here, but of course you can't convert it.
Now,
so if you want to see this one in hex, you would just do data print space -x.
Now, the Manchester piece makes sense because we know that this key fob that we're using uses Manchester 2 for its encoding. So it makes sense that the LF would probably use Manchester as well.
Yeah, that makes perfect sense. It shows perfectly coding in that sense. So yeah, I would agree with you there.
So this right here, as we look at it, we now have the ability to look at it in binary. We can look at it in hex. But if I wanted to, could I actually replay this signal so that I don't have to replay it from a hack RF or a Portapak or another software-defined radio? Could I actually replay this with the Proxmart?
Actually, that is a very good question, and you are absolutely correct. You can. And there is the possibility to simulate things right off from a raw signal. And you find that under the command lf space sim. If you go for lf space sim -h, we can give some options on it. And I will just give you a hint, because this, when Portapak simulates something like this short signal, it keeps on just sending it on over and over and over and over and over and over again. And what you described to me a little bit earlier was that this key fob sends an answer every 2 seconds or even 1 second. So we might need a stopgap. So if you do an lfsim space --gap, and then it's microseconds, so we need to put in 1000 for 1 second delay. So every second it would send this signal, and then it would wait, and then it would send it again. If you press enter, this is what the Portapak is doing now. It would send this signal over and over and over again with 1 second's interruptions, intervals. Kind of awesome, I would say.
Yeah, so now we've kind of come full circle and wrapped the whole thing up in a nice little bow. We can do the 315, 433, 868, 900 megahertz area of collection and demodulation. We can demodulate the LF side of it using the raw, and now we can put it together and start doing some comparisons. I really appreciate you stepping in for this talk and showing this. I think that this is one of those things, people look at the Proxmart sometimes and they think it's just a tool to try to clone hotel keys, which I'm getting ready to do momentarily. But there's so much more you can do with it, and I think it goes hand in hand with a lot of the stuff that the people in the software-defined radio world are doing. So thank you so much for helping with this, and I figured it was best to go to the person that knows this better than anyone else, so that's why I went to you.
Thank you so much, Woody.
All right, well,
remember, we're all standing on the shoulders of giants here. Remember that.
Absolutely. Thank you again for your time, and I appreciate it. And for everyone who's watching this right now, I'm going to get ready to do a big wrap-up and summary momentarily. But for this piece of it, the Proxmart section of this and the LFD mod, I think with what we've shown you, you should be able to get out there and really start doing some good stuff and start feeding some research our direction so we can start helping each other.
Yeah.
Okay, I am getting ready to wrap up. I just want to go over a couple of the simple things that we should look at moving forward. If you're going to attempt this, again, whatever you do is on you. I give no legal advice, and I do not give any disclaimers about this, whether you should or shouldn't do it. I do this for a research or from a research point of view and trying to get better at my trade. Always explore, find new ways to use hardware, try different things, and you may be able to find something that you didn't know was possible and run it even further than you thought. I didn't realize that the Hack RF would do so well at 125 kilohertz. I saw a video by Mike Osmond where he was playing around with it, decided to give it a try. I want to again thank Iceman for helping out with this video. He made it much smoother, and that should help some of you be able to figure out what is out there and how to actually demodulate the LF signals around you. Start looking at the things around you, enjoy it, have fun with it. I hope you enjoyed the talk. Thank you again for everything. And the guys at the Village, I wish we were all together doing this live. Any of you that are watching this, I am in Vegas at DEF CON, so if you find me, I'm happy to answer questions. So thank you again, and enjoy your day.